What's going on, guys? An update to the over Unity receiver circuit. I combined multiple of the receiver circuits, multiple of the ground receiver circuits, plus a resonant transmitter, and our input is under 15 watts. Our output is 1.77 amps at 80 volts. And here's the interesting thing. When I connect this light bulb, this load, my power consumption will drop. So I will connect this incandescent light bulb and my power consumption will drop. And there we go, it dropped. I'll zoom in on the load. Incandescent light bulb lit very bright. So keep in mind he is lit from our multiple energy scavenging circuits when the transmitter is on. Again, load disconnected, power consumption goes up. Load connected. If I can make a good connection, power consumption goes down. And keep in mind that occurs and we still have radiant energy. That should be impossible. I could keep duplicating the receiver circuitry anywhere I want for all the power I want. And that's a little mini 10-watt incandescent. And he runs without putting a drain on the system? How is that possible? Can you see that? Disconnected, transmitter consumes 14 watts. Connected, transmitter consumes... It's a bad connection here, hold on. Transmitter consumes, yeah, 12.86. How weird is that? I'm telling you guys, we found the solution. Oh, that's hot. We found the solution. I think we cracked it. We pretty much cracked limitless energy extraction. I'll show the short circuit current again. Well, voltage first. Voltage at the extraction circuit is 83 volts DC. And keep in mind, I didn't even put this output yet through a pulse discharge circuit or a special converter board, DC to DC converter board. I could optimize it even further. And our amperage output is 1.86 amps and climbing. Oh, no, dropping. It's a little unpredictable at times, but it does stay pretty high. We have an output of 1.69 amps. We're putting in 270 milliamps at 50 volts, consuming 13.5 watts. Short circuit current 1.67 amps. Open circuit voltage of the combined receiver circuits is, and of course it fell. When we start filming, everything goes wrong. 75 volts, make sure this ground connection is in good. Okay, so this is one of my ground extraction circuits. It just connects right into ground. Just gotta make sure it's in good. Come on. Still didn't get it. There we go, I think I got it. Okay, I got it back. So we'll check short circuit current again. I gotta be careful not to blow my milliamps. 1 point, oh there we go. I don't think something's making good contact in here. There we go. Okay, so And for those that don't know, when the transmitter's on, if you put a full bridge rectifier between two separate ground points, you will get energy extraction. And the rectifiers are 1N5819 diodes made out of these diodes. So keep in mind we have that short circuit current while simultaneously maintaining the wireless power. I'm telling you, man, it's something here is getting crazy. Again, I'll connect the load. Well, I'll show you what the load consumes for current. The load is consuming more current than is in our power supply. 340 milliamps. Next, we'd have to read voltage while the load is lit for an accurate reading, but it's just crazy. Again, I will connect the load. You will see how the power drops. There we go. It like settles itself or something. The receiver circuitry. So he's lit full power. And the radiant energy effects usually enhance when this happens. Keep in mind there's no degradation of that bulb. So we're at a point where we can light incandescents now. And if I turn that up to 15 watts, I'd get 3 or 4 amps at this extraction circuit. And I'd begin to melt my diodes. This is where all the connections terminate into parallel configuration. I can even add another receiver coil. Keep adding multiple extraction circuits. It's just getting wild. You get power from 2 separate ground connections with a full bridge rectifier in the center connected to the AC sides. AC sides of the rectifier connect to the 2 separate grounds and you got output. And you can keep duplicating that circuit when the transmitter's on. So keep in mind that's going, the incandescent. We still have this. Phenomenal. I can add more extraction circuits here, combine the output. The real key was the diodes, is what did it. The hyper efficient Scotty diodes with quantum tunneling effect. So, it's getting very interesting. I'm gonna try and keep this video under 10 minutes. Extreme radiant energy. No limit to what we can do. This system is acting as a generator now once started. That is hot. What kind of effect causes that? The circuit consumes less power when the load is connected. Never heard of that effect before. And again, I'm going to push it a bit. We're going to set this to current. I'm going to see how much amperage I can get out of it. I'm going to take it to under 20 watts. Okay, we're under 20 watts. That is bright. That is hurting my eyes to look at. We'll see how much current we have now. How much short circuit current is here. Whoa, that sparked. We have 2 amps short circuit current. And if it goes to 3 or 4 amps, we'll start melting the diodes. They'll start heating up. Two amps. And while that's shorted out, we still have wireless power effects with an input of 18 watts under 20. So this is our combined receiver circuitry getting us 2 amps at 75 volts. And keep in mind, I could keep replicating the circuit, the receiver circuit, in different spots of the room and combining the output for even more power. So again, and we'll see how much current the load consumes now. Load is consuming a little under half an amp. The load is consuming more current than the DC power supply is supplying from our combined receiver circuitry. So I'll keep this light lit. That light alone is probably using 10 or 15 watts. I'm gonna try and get a fluorescent tube lit. Put him right here. He's lit. That light is kind of just drowning it out. There we go, he's lit. You can clearly see that. Look, incandescent is so bright it's drowning out the fluorescent. Only consuming less than 20 watts. I'll try and clamp it. Okay, I clamped it. So now we're even more efficient because I clamped the current. That's just nuts. No degradation at all. Absolutely no degradation. That's wild. So yeah, it's getting interesting. And Jesus, dude. This is definitely a generator. That relay coil in the center is key too. So I get my hand near it, it dims out. It's all about tuning. Damn, man. And I didn't even scratch the surface yet of what this thing can do. Oh, it was getting hot. This is exciting. And for the naysayers, so I'll shut the system off. It all goes out. So that's that, and it's getting very interesting. I think we're already at the more than the break-even point in the receiver circuitry. So that's getting interesting. And another idea I had, because it seems we can light an unlimited amount of these LED lights, another idea I had is to get a flat top LED receiver light and put a photodiode on the other side. And a photodiode would convert the light into a small amount of DC electricity. So, because we have an abundant light output with this system, so that might be one solution to get even more, scavenge more additional extra power. So that's that, and I'd like to say thank you again to everyone, and it's getting very interesting. Stay tuned.